Me e-learning platform. I'm Purnima. Here we are going to discuss the second chapter of mathematics class 11, that is relation and function, and today's topic is relation and its domain, range and codomain. Now students, we know about the Cartesian product between two sets. If set A is 1 2 3 and B is AB, we write A Cartesian product B is equal to 1A 1B 2A 2B 3A 3B, like that. Now today we are going to discuss what is the relation. Now what is the relation? Relation is also a ordered pair where these relation is the proper subset or almost the subsets of A cross B, that is the Cartesian product of two sets. Students, what is its domain? Domain of the relation is its x coordinate. When we count all the set of x coordinates of the ordered pairs is said to be the domain, and the what is its range is a set of all second coordinate of y, that is the ordered pair, is called the range. Let us see some example of it. Here we have some examples like that. Given the relation is 2 minus 6 1 4 2 4 0 0 1 minus 6 3 0. What we count first coordinate of it, that is x, means 2 1 2 0 1 3 0 1 2 3 be its domain, and the next coordinate, that is y coordinate, is minus 6 4 4 0 minus 6 0, that is minus 6 0 and 4 be its the range. By this way we find the domain and range. Now let us take some graphical examples like that. Here is the 4 points is 5 points is like that: 2 3 minus 4 3 minus 1 minus 2 0 minus 4 or 3 minus 3. Students, see here 2 is the x-axis, 2 represent x-axis and 3 represent the y-axis. All these values of all these pairs are like same. First one is the represent the x-axis and second one represent the y-axis. We write these ordered pair in here and count the first element of it, means x-axis. X-axis element is minus 4 minus 1 0 2 3. These are the domain. And what is its range? Minus 4 minus 3 minus 2 and 3 is its range. By this way we find the domain and range. Now next thing is that what is codomain? The range is proper subset of codomain. This is the very noticeable thing, is that range is always the proper subsets of codomain, or we say that codomain is a set which consists all the elements of range. Let us take an example. Let us set A is equal to 1 2 3, B is equal to ABC, and the defined relation is 1A 1B 2B. What is its domain? We count the first element 1 and 2 is its domain. What is its range? A and B be the range, but where the range belongs, that is the set B. Set B, set B consists all the elements of range. That's why we say that range is the proper subset of codomain, or subset of, or also the subset of codomain. Maybe it's equal. ABC is also present in range. It's possible, have a possibility. That's why we codomain is the set B. The range is always the proper subset or subset of codomain. Now see, for the explanation explorers or the topic, we here to explain the exercise 2.2 of our NCERT book. Now let's see the first question of it. What is the first question? Let A is equal to 1 2 3 14 and define the relation R from A to A. R is equal to xy, 3x minus y is equal to 0, xy belongs to A. Find its domain, range and its codomain. Now see the students, relation R from A to A is defined as xy, 3x minus y equal to 0. We take this y like that side, means what? Y is equal to 3x. Every value of x, y is equal to 3 times of x. That's why when we opt x is equal to 1, we get y is equal to 3, x is equal to 2, we get y is equal to 6, x is equal to 3, y is equal to 9, x is equal to 4, y is equal to 12. Yes students, we stop here because we never opt the x is equal to 5, because here is some restrictions is that xy both belongs to A. When we put 5 now, we get 15. That 15 is not belongs to set A. That's why we close here. So this is the 1 2 3 4 is its domain, and the range is, and the range and the codomain of it is 1 2 3 14, where range belongs, and its range is 3 6 9 12. Now come on the next question. See the question number 2 of it. Define a relation R on the set N of natural number by R is equal to xy, where xy is equal to x plus 5. X is the natural number less than 4. It is here the restriction. X is less than 4 means we opt only 3 value, that is 1 2 3. When we put x is equal to 1, we get y is equal to 6. X is equal to 2, we get y is equal to 7. X is equal to 3, we get y is equal to 8. Now what is its domain? 1 2 3 is its domain, and what is its range? 6 7 8 is its range. By this way we find the range and domain or codomain. Now see the third question of it. A is equal to 1 2 3 5 and B is equal to 4 6 9. Define a relation R from A to B, x y. The difference between x and y is odd. We consider only those pair of elements whose difference is odd, means whose difference is 1 3 5, like that. Now here what, the difference between 1 and 4 is 3, 1 and 6 is 5, 2 and 9 is 7, 3 4 is 1, 3 6 is 3, 5 4 is again 1, and 5 6 is 1. It may be minus 1 or plus 1, it does not matter, but the pair only, we consider only those pair whose difference is maybe minus 1 or plus 1. Okay students, now come on the next question, that is question number 4. The given figure shown in the relationship between the set P and Q, this one the set P and this one is the set Q. Write this relation in the set builder form, in the roster form. What is its domain and range? First we write it in the set builder form. What is the relation between these two sets? Is the, here we observe here 5 is paired with 3, 6 is paired with 4, and 7 is paired with 5. What is the difference? What here we observe now कि first element set A is, when we opt y is equal to x minus 2. If x is equal to 5, so how we get y? Y is equal to x minus 2. So this is the form. First is our set builder form. R is equal to xy, y is equal to x minus 2, where x belongs to P and y belongs to Q. Or we say that R is equal to xy, y is equal to x minus 2 for x is equal to 5 6 7. Its pair comes like that, 5 3 6 4 7 5. What is its domain? 5 6 7 is its domain. And what is its range? That is the 3 4 5 is its range. Now like that we solve all these things. Now come for further the next question, that is question number 5. Let A is equal to 1 2 3 4 6 and let R be the relation on defined AB. Here relation is like that, B is exactly divisible by A. We consider only those elements, those pair of elements where B is, means Y is exactly divisible by X. Now what thing is that every number is divisible by 1, is clear? 1 1 1 2 1 3 1 4 1 6. Now come for the 2. 1 is not divisible by 2, that's why we never consider 2 1. So 3 is not, 2 2 is divisible, 2 2 2 4 2 6. Come for 3, 1 is not divisible by 3, 2 is not divisible by 3, 3 3 and 3 6, 4 4 and 6 6. What is its domain and what is its range? Its domain is 1 2 3 4 6 and its range is also 1 2 3 4 6, because we here we see all these numbers comes in both the times, x time or y time. Determine the domain and range of the relation R defined by R is equal to x plus 5. We have already discussed this type of sums. X or y is equal to x plus 5. What we get? X is equal to 0, y is equal to 5, x is equal to 1, y is equal to 6, x is equal to 2, y is equal to 7, x is equal to 3, y is equal to 8, x is equal to 4, y is equal to 9, or x is equal to 5, y is equal to 10. What is its domain? 0 1 2 3 4 5, and its range is 5 6 7 8 9 10. Okay students, now we move for the next question, that is question number 7. Write the relation x R is equal to x cube. X is prime number less than 10. We know the prime numbers is 2, 3, 5 and 7 only. When we x is equal to 2, y is equal to its cube, that is 8. X is equal to 3, y is equal to 27, x is equal to 5, y is equal to 125, x is equal to 7, y is equal to 343. So like that we write all this relation. Now come for the next question, that is question number 8. Let A is equal to xyz and b is equal to 1 2. Find the number of relation from A to B. How many relations will form? The first of all we find the it's what Cartesian product. Now what is the Cartesian product? Cartesian is x1 x2 y1 y2 z1 z2. Okay, now what is the how many numbers of elements in its Cartesian product? That is set 6. How many relations will form? That is the subset of the number of subsets of Cartesian product is the number of relations formed between A and B, that is 2 to the power 6. Now come on the next question, that is question number 9. Let R be the relation on Z defined by R is equal to AB, where AB belongs to Z. A minus B is an integer. Student, find the domain and range. Student, we know about any numbers. It's known that the difference between any two integer is always an integer. That's why our domain is also an integer and our range is also an integer. By this way we find the domain, range and codomain of relation. Okay student, thank you. We move for the function and watchful for the next video.